and welcome to the Microchip Is podcast. Join your host, Mike Maynard, as he learns about the technologies, products, and people that make Microchip Technology what it is today.
Welcome to the Microchip Is podcast. I'm Mike Maynard, and today I'm finding out that Microchip is timing in space. I'm joined by Dave Bale. Dave is the Director of Oscillator Products at Microchip Technology. Welcome to the podcast, Dave.
Well, thanks, Mike. Glad to be here. And as you said, yes, I'm the Director of the Oscillator Products here within Microchip. Just a little bit of my role and what I do is we have two different design and manufacturing locations for our quartz oscillators. We're here in Mount Holly Springs, Pennsylvania, as well as Neckarbischensheim, Germany, are our two locations that we have. Both these locations have design and manufacturing capability for our quartz oscillators. Today, we're going to talk about our space products, but I did want to just give a little bit of background. Quartz oscillators are used throughout the industry and in all markets: communications, industrial, downhole oil drilling. Anywhere you look, you're going to find a quartz oscillator. The space market is currently our largest and fastest growing market and the most evolutionary right now. So that's what we're going to focus on today during this podcast. I've been with the company for about 30 years, so I've experience in all these different industries. And actually, our heritage in space goes back to the 50s. So we've been in space for over 70 years with some of our products. So very, very deep history for our space products.
I love the fact we're going to talk about space. You know, it's such an exciting topic. Let's start off. You mentioned that it's one of the markets that's changing the most at the moment from an oscillator point of view. So what are the big trends you're seeing in terms of the space market?
Yeah, that's a great one. And as I said, I've been in the market for quite a while. If I go back 10, 15, 20 years ago, if someone had a need for a space product, you knew what they were looking for. They were looking for a high reliability product. They were concerned about mission life, very dependent upon the heredity of the product. They wanted to buy it. They wanted to be 100% guaranteed it was going to work and meet their mission life or exceed their mission life. The other thing that the majority of the space customers years ago were either government agencies or defense applications. When you look at it today and you look at the new space requirements and the large mega constellations that are going up, there's a huge shift in the market where it's really focused on commercialization. How quick can we make money off these satellites that we're putting up there? And it's changing the whole market structure. The focus is now risk mitigation, trading off risk with cost, with lead time, to how quick we can get the technology up there and how quick can we start generating revenue on the product. So it's huge shifts in the markets over the years that I've experienced.
It sounds like a really big change in the requirements for the products. But I mean, before we dig into the products, you know, what's driving this new space market, as you talked about? You know, what are the services they're providing?
Very, very broad, and it continues to grow. You can put them into some major categories. Communications is a huge area for satellites. It used to be more traditional, where military communication, satellite radios for military, but now you're seeing it supplementing cell coverage. You get into a dead area with your cell coverage, it'll switch over to the Starlink constellation and be able to do that. A broadband internet for areas where the internet can't reach. Even in-flight entertainment in the airplanes used to be ground-based. Now it's going satellite-based. So the communications aspect is everywhere. There's global asset tracking. Shipping companies want to know where all their containers are. They want to know where other tractor trailers are on the roads. They can do global asset tracking with this. Earth observation. So again, used to be for the government typically wanting to map the Earth, but now you're seeing it precision agriculture. Where do we need to go water? Are we in drought conditions? Are we in flood conditions? This will all be mapped. The other thing that we're seeing is some people have short-term needs, and they can actually rent satellites now. There's companies out there that are renting out their satellites for certain specific applications for certain time periods. There's the traditional GNSS or global navigation systems with GPS and Galileo, but even those we're seeing alternate technologies with mega constellations to help with positioning and guidance. And lastly, you're hearing it in the news, is tourism. There's actually people wanting to take flights in space just to say they can.
That's such an amazing range. I mean, just going back to something you said earlier, you know, you really focused on the fact that these companies, this new space market, they're really keen to like move to revenue quickly. So how does that affect the way that the engineers and designers think when they're choosing and using products?
Yeah, that's a good question. There's definitely been a shift. When we look back over the past decades, a lot of the decisions have been made on, as what I mentioned previously, the heredity, the reliability that goes into the parts, the screening requirements for some of the components that we have to buy are they can take 6 months for screening requirements and be highly costly. Where a lot of the designers are now looking towards COTS parts or maybe automotive grade parts, and they're willing to do that risk trade off with lead time with cost. If I go back to traditional space a few years ago, if someone was putting up 5 or 10 or 15 satellites, or take the GPS constellation with 24 satellites, that was a huge constellation a few years ago. Now you're hearing constellations going up in the thousands of satellites. So there's now volume manufacturing involved that where if you try to enforce some of the quality requirements, you just won't be able to support the volume that's needed in the time frame to launch these platforms. So not just a trade-off for risk, but also for lead time and getting the technology out into space. The other thing that's interesting too is with some of these CubeSats, really small CubeSats, you can test out technology for relatively cheap. You can try something, put it in there. Will it survive the radiation? Will it work? And it's a relatively low cost, where in the past, you might test something out for 2, 3, 4 years before you're willing to put that new technology into space. So many different aspects, but yeah, it's clearly a shift in the mindset of the engineer as they're designing these products.
I mean, that's an interesting shift because obviously compared to a lot of applications, they still need incredible levels of reliability, but much less than traditional space. So, I mean, presumably they're trading like cost and time with some element of reliability, but not all of it.
Absolutely. So you have to give something up in order to be able to meet the cost targets, meet the delivery targets. And it's not a free for all. It's very calculated as to what they're going to do and what they're going to trade off. For example, if you look at traditional requirements, every wafer lot's going to be verified, every component's going to be verified on that lot that's going in there. You have homogeneous lots. They may look at it for a new space application. Let's prove out the technology, and the technology is repeatable. So maybe I don't need to qualify each specific lot, but I can qualify the technology and it's repeatable enough, and it lowers the risk. Okay, I want to make sure it's clear they're not throwing caution to the wind, but they're being very calculated in what they're doing to try to do the trade-offs between reliability and performance.
Yeah, and presumably ultimately aiming for reliability, but without the expense of proving it, I guess. I mean, is there anything they're actually going to lose in terms of, some of the things that the traditional space market used to demand?
Absolutely. When you look at the traditional space market, one of the things is long mission life. A lot of the satellites shoot for a 15 or an 18-year mission life, and they tend to exceed it. I can give an example. We actually have components on the Voyager that was launched in 1977, and it's still sending images back to Earth. So that will most likely not happen with some of the newer designs going out there. And that's not their design goal. That's not what they're targeting. The other thing is, because of the relaxed radiation requirements or other requirements that they may not be able to meet, they're going to be limited in the orbits that they can use. And most of these new space applications are low Earth orbit, not in the Van Allen belt or other areas with high radiation. So you're going to give up on some of your flexibility on your orbits that are available to you. The other thing is, although the cost is much lower, you may need more redundancy. You may say, well, if I put up 50 satellites and I lose two, oh, well, I still got 48. I can still accomplish my mission. That wasn't a mindset in the past, but those 50 satellites might be a lot cheaper than the 5 traditional satellites. So they're willing to make that trade-off. The other thing that we do think is going to be given up is some of the 100% uptime. When you look at some of the radiation effects, like single event effects, you can have transients or you can have latch up effects that will affect the product. Transients, if there's an effect, you may have a temporary interruption of your signal, and it will come back. Typically for traditional space, you want something that's immune to these effects. For new space, you will have to live with these. whether you operate through the transient. Maybe you have a latch up situation that requires a reboot. It's not destructive to the unit, but maybe you're going to have some downtime as you deal with these single event effects that you maybe have designed out or made immune in your more traditional systems. The other thing that's interesting is you may not have as much control over your launch window. There's a lot of ride sharing for Uber in space, where basically you're going to share a ride on a launch vehicle to lower your cost of launch, but then you're more at the mercy of others to when the launches are going to be available. So it can dictate your production schedule and what you need to do to be ready for those launch windows. Yes, there's definitely a lot of things that you give up, but in the end, it ties back to cost and time to get the satellites up there.
I mean, that makes sense. And, one of the things you said was around, trusting the technology. I mean, presumably there's a lot of trust in the vendor here. You've got to feel as a customer that the vendor's going to deliver the quality that is going to prove reliable in operation. So, I mean, what is it with Microchip that means that customers really trust you to deliver reliable space products?
Yeah, so I mentioned it, but part of it is our long history. We've been in this market for decades, and we've seen the transition from traditional space into new space. And with that transition, we understand our customers' needs. We understand the trade-offs. The other thing that's a little bit different with us versus some people in the market is we have both solutions. So we're not trying to force a solution down our customer. We really want to understand what are their mission requirements. What are your radiation requirements? What are your reliability requirements? What are you going to be operating in? And let us make sure we can offer you the best product and the best solution for those applications. One other piece of that is not just with our long history, but I mentioned at the beginning that we're in all different markets. So if we look at some of our communications business, we're used to doing hundreds of thousands of oscillators a month, with our production volumes. We can leverage some of the quality inherent with automated production into some of our space products. We have a very long history of military business and defense products, and we're used to working to the MIL standards. We're AS9100 certified, which is the aerospace quality standard. So we can leverage our history, we can leverage our experience to make sure that we're delivering the product that best suits the customer's needs, not just for performance, but for long-term reliability, regardless of their mission life.
And I mean, that's interesting. I guess I've got to ask you the question from another point of view as well. Because you've got this history in traditional space, does that make it more difficult for you to respond to this much more agile, much more flexible new space market?
That's a great question because change is always difficult. And I will say, I think if we go back 5, 6, 8 years ago, it was a little bit more uncomfortable for us for that. But I think we've seen the market and we understand the trends and we know what's going on. And because of that, we've actually created a whole new product line to go after new space requirements. Because in some cases, not everything is clear cut. There's some traditional space requirements, and then there's some new space requirements that are very close to COTS parts that are flying, but there's everything in between. And we've created a series of products, which we call the L series products, covering the spectrum of clocks and TCXOs and OCXOs and modules that are targeted at specific radiation requirements. What we typically see in the low Earth orbit is about 50 K-rad total dose, and we're looking for latch up of about 40 MeV centimeters squared per milligram is the requirement that we test all of our L series products to. But if a customer comes to us and says, but I need something more, or I need this, or I need a single lot date code, or I need homogeneous lots, we're willing to talk to them and figure out what they need, and we can come up with that. Also, with our breadth of products that we have for our traditional space, we've looked at, do we remove requirements? Can we get rid of some of the quality requirements we have the heredity on the products, but maybe we're not assuring that particular lot, but going back to more the technology assurance of those type products. So the broad breadth of products and the experience base that we have has allowed us to adapt to the requirements for this new market. But like I said, maybe 10 years ago, it wasn't so easy, but we've adapted to the market, and we are absolutely, I think, leading it at this point with some of the innovations that we have for our new space products.
I think that's really positive and really honest that, I think engineers, when they listen to these things, they hate for everything to be perfect and easy. Everybody knows those challenges, and it's great that you face these problems and overcome them. It sounds like you've got quite a range of products you offer for timing in space. You mentioned a few. Do you want to just give a bit more of a detail about the product families you've got?
Absolutely. So if we look at, with our traditional products, so as I mentioned, I'm responsible for the quartz oscillator products, but we also have atomic clocks that go into space. We provide some of the timing references on the GPS satellites with some of our atomic standards. But when you look at our portfolio, we do everything from just a crystal. There's some customers that don't want an oscillator, they just want the crystal and they want to make their own oscillator. We have those products all the way up to clocks, to temperature compensated crystal oscillators, oven controlled crystal oscillators. If you need a voltage controlled oscillator to go into a phase lock loop, we have those products as well. With data rates going higher and higher, we're seeing the frequencies going higher. So we have VCSOs, voltage controlled SAW oscillators, which can go up to a gigahertz in frequency for higher frequency applications. And then oven controlled crystal oscillators, we have some smaller form factor parts, but we also have master reference oscillators that are OCXO based. So within the oscillator portfolio, we have an extensive product line for those type products. It is the broadest portfolio in the market. And this is where I mentioned before, if there's a need, we'll have the right product for it. We don't have to force fit a product into the solution.
That's really interesting. I mean, a lot of products there. I'm interested. We've talked a little bit about some of the semiconductor issues around latch up and things like that. What are the challenges of actually making like quartz products work in space? Is that difficult to do without incurring lots of cost?
So the challenge with making a quartz oscillator radiation tolerant is twofold. There's really two main aspects to making a quartz oscillator rad tolerant. One is the quartz itself. All quartz that's used today in oscillators is synthetic. Synthetic quartz is much purer than natural quartz. But even synthetic quartz is not pure enough. The impurities within the quartz, when exposed to radiation, can cause displacements within the lattice structure and cause a frequency shift of the oscillator of the quartz. So we go through a sweeping process, and you take the raw quartz before it's cut into a crystal used in an oscillator, and you go through a sweeping process, which is high voltage, high temperatures, and it displaces the impurities over to one side of the quartz, and then you physically remove those impurities, and you end up with a higher purity quartz. So that's called the sweeping operation. So now you've got a good piece of quartz that's immune to radiation. The next challenge is, as you mentioned, is the semiconductors. We use plenty of semiconductors within our products, so we need to assure that the semiconductors are radiation tolerant. Being part of Microchip helps us with that. There is a plethora of products within Microchip that we use as part of our components within our oscillators to make our parts for new space as well as for traditional space. There's products within the Microchip portfolio that significant legacy and heredity for traditional space, but there are automotive grade components and other components in the Microchip portfolio that we're moving into rad tolerant and taking the technologies and converting them into rad tolerant. And we can use those as building blocks within our oscillator products as well. So definitely an advantage to have access to a lot of rad tolerant silicon products within Microchip.
I mean, that sounds like there's a lot to think about there on the semiconductor and the quartz side. So it sounds like there's a challenge. I mean, we've talked a lot about new space. I'd like to change track a bit now. Let's look at this, I think what you call traditional space, the higher orbit applications, where you mentioned, for example, there's very high radiation. I mean, how do the requirements differ?
Yeah, so I mentioned briefly about the long mission life and the higher reliability, but when you get into the details and the specifics, the radiation levels are definitely higher. As I mentioned, a lot of customers have higher radiation requirements, 100 kilorad total ionizing dose. We have products up to 300 kilorads total ionizing dose. So extended durations in space, that's part of the long mission life. It also depends upon where you're operating. As I mentioned, with low Earth orbit, you're limited to certain orbits. We have products that operate in the Van Allen belt, which is very high radiation. So you have the radiation aspect of that, both for total ionizing dose as well as being single event effects and making sure that you're latch up immune or you don't have transients. And it can be some very high LET rates, dosage rates up to 70 MeV centimeter squared per milligram for some of the LET rates that you need to perform through those single event effects. That's the radiation piece. The reliability piece ties into what I mentioned before about proving every lot, proving every component. We have to go through element evaluation for the components that we buy. It can increase, 8, 12 weeks of screening time just to get the raw components in. We build parts to homogeneous lots. So everything within the lot is processed at the same time. There's traceability that we know exactly which components and what serial numbers went into each device. There's a significant number of analyses that we perform before we even put the first part together of the product. We'll be doing worst case circuit analysis and end of life analysis and thermal analysis, stress analysis to verify all the performance parameters throughout the life of the device and anything it might encounter in its environment. So those are a lot of the things that differ. Again, on our new space, we'll do a lot of those on the platform and the technology. But a lot of times for traditional space, you're doing it on each design, on each part to verify compliance and assure 100% mission success for every device.
It sounds like it's a lot more than radiation hardness, Dave, that you've got to do to, actually meet the demands of that traditional space market. I mean, you've listed a number of challenges there. Are there any other challenges you have to overcome for that traditional space market?
There absolutely is. As you said, radiation is large, and we talked about the reliability and the challenges there. But another part of this that can't be overlooked is survival through launch and vibration and shock. The vibration levels of the launch can be quite high. There's also the pyrotechnic of the separation stages that you have to survive pyrotechnic shock. So not only is it from an electrical standpoint and doing all your simulations, but making sure you're doing the mechanical stress analysis that your part will survive mechanically through all this. And again, this is where we'll do finite element analysis and other analysis to assure the robustness of the design. But again, we can build on our long heredity of products. We've been making products for the military market for 60, 70 years. In addition, we do components for the downhole oil drilling market, where we have oscillators that have to go in the tip of a drill bit that's going a couple miles down into the earth, extremely high temperatures and extremely high vibration levels, and we need to operate through that. We can apply that technology to the products that we put into our space products. So it is a challenge to overcome some of the shock and vibration requirements for launch and the separation stages. But with our bag of tools that we have the capability to incorporate those and ensure success.
I mean, one of the things I'm wondering now is, you've got such a range of things you've got to do to qualify for this really demanding sort of application. I mean, how does Microchip go about qualifying products for more demanding space applications?
So when we look at traditional space, there's part of this is MIL standards. We work to MIL PRF 55310, which is the military specification for quartz oscillators. Within there, there'll be qualification requirements and screening requirements that we need to follow. There's also another major specification we follow, and it's MIL PRF 38534. And that's a specification for hybrid microcircuits. And again, the qualification requirements are spelled out within there as far as what we need to do to qualify the parts. So typically, the products are qualified to the MIL standards. In many cases, we have customers that have their own qualification schedules and qualification plans. Although we have a very broad breadth of standard products, we do quite a bit of customization as well. If a customer needs specific tests on, we can do that. We typically start with our standard platform, and then we modify it or modify the testing or screening or whatever needs to be done for their requirements. Typically, when we go through this for our traditional space, we'll go through checkpoints through the process. We receive the order, we start the design. We'll do a preliminary design review with the customer, where some of the analyses will be reviewed for the design. The worst case circuit analysis, the end of life analysis, the finite element analysis will all be reviewed. When it comes time to start building, prior to building, a lot of times we'll do a manufacturing readiness review with the customer, review all the production documentation. Are we good to build it? agreeing with all the processes that we're going to use. And at the same time, a lot of times in parallel or just before, we'll do a critical design review. Once the design's finalized, the prototypes have been been built and evaluated, whether the prototypes are engineering models, review that data, make sure we're meeting all the parameters. So we have several checkpoints throughout the process, as well as following the military specifications I referenced or the specific customer qualification requirements. But with our test capabilities, the majority of this is done in-house. We have a full environmental test lab. So it's a benefit we have that we can control our qualification schedules and the testing that we want to do with our in-house capability for the majority of the requirements that are required in the mill standards.
I mean, that sounds incredibly complicated, even with your own in-house test lab. I'm interested that this traditional space application product, are they still similar to new space, or are they really just completely different?
So when you look at a high level and you look at, let's take an oven-controlled crystal oscillator, uh, and you look at that and you look at the spec sheet, if you're looking at the performance specs, you're not going to see a whole lot of difference between a new space and a traditional space part. When you start seeing the radiation requirement differences and you start seeing the reliability requirement differences, then it changes the internal design. To meet a lot of the reliability requirements for some of the traditional space products, it's hybrid construction. It's a class 2 hybrid per mil PRF 55310. So it's bare die, chip and wire bond, in hybrid packages. When you look at a lot of our new space for oven controlled crystal oscillator products, they're mixed technology. They're FR4 based. They'll use a sealed crystal and plastic encapsulated ICs and semiconductors versus bare die. So at the high level, the description and the specs of the products are very similar. But when you get into the design details, they do differ to meet the requirements for the two different market needs for new space and traditional.
That's fascinating and amazing how you've got to take effectively two approaches to build the same product based on the requirements. I mean, Dave, this has been fascinating. I've loved talking about this. Before I let you go, I've got a couple of questions. And one of the things I'd really like to know, you mentioned the Voyager mission earlier, but can you give us some more examples of some of the missions where microchips provided timing?
Absolutely. And if we had another 45 minutes, maybe I could touch them all. But what I'll try to do is maybe go through the different applications, like launch vehicles is an area that we have products on, and we're on the ULA Vulcan Centaur rocket. If you look at communication satellites or constellations, we're on OneWeb. I mentioned GPS-3, right? If you're looking at government type satellites or defense type satellites, we're on GPS-3 in Galileo. The GOES-R is a weather satellite. So we're on all the different GOES. There's several different, I think they're up to GOES 16 now, and we're on each of those. We're on manned space vehicles. We're on the Orion program. We're in the International Space Station. Space telescopes. We're on the James Webb Space Telescope. We're on the Mars rover. We've been to Mars. We're actually setting the time standard on the moon. There's going to be a time standard put on the moon, and we're helping develop that. So it's everywhere. Space is literally limitless when you look at what's going on in space. It is mind-boggling. You stop and think of all the different applications that are going on.
I mean, it's amazing the range of products and the history you've had in space. I mean, presumably the timing products from Microchip, they're not alone. You also have other products in addition to quartz for space applications?
Absolutely. So like I said, I'm responsible for the quartz products, but our frequency and time system group that I'm part of, we also do the atomic standards. So there's cesiums and rubidiums, again, for new space and traditional space for those applications. We have SAW filters. So for anything that's being transmitted that requires filtering, we have surface acoustic wave filters for those applications. But FPGAs, we have Ethernet 5s, we have microcontrollers, diodes, transistors, voltage regulators. It's across the board. If you go to Microchip, you can go to the space section on the website, and you will see the full breadth of products for the space market.
Dave, it's been fascinating. You covered so much today. I'm just wondering, if you were to sum up, what's the most important thing to remember about Microchip and timing in space?
So I think one of the things that's most important to us is our deep understanding of the trade-offs between the risk and the reliability. I won't go through everything we discussed previously, but that allows us to get the right product for the mission with our product breadth and our experience base. we're going to have the solution to whatever problem a customer can put in front of us.
That's great and really straightforward and simple. One question we love to ask all our guests, because we've got a big engineering audience listening to the podcast, what's the best engineering advice you've had that you could share with listeners?
One of the things I would say, probably the most important, is contact us early. What we see is sometimes engineers will find a solution and they start going down a path, and it may not be the ideal solution for what they're looking for. Contact us early. We can get them started in the right direction. And then later on, when it comes to finalizing the specs, I think we're going to be much better off on both sides. The other thing that I like to recommend too is we have many tools that we try to help teach our customers about our products and our technology, not just our products, but the technology. How does it work? That way they can have a better idea as to what's the best solution for what they need. We do frequency control universities where we bring customers on site, and it's a technically based university where we go through the technology of the oscillators to help know, do I need an OCXO or do I need a TCXO, or what's going to be better in this environment versus that environment. We also have many tools online, mission assurance videos and other training tools online to help educate our customers into the products. One of the things that we have seen with new space is an explosion of new customers. The number of entrants into the new space, the hurdles to clear to enter the new space market are much lower than they are for traditional space. And there's a lot of customers that are new to the market. So we have a lot of tools out there that help get them familiar with the product and the capabilities that we have. So definitely invite them to the website, reach out to us, attend one of our universities. I think it's the best way that we can get the learning across to our customers and get the right product designed in.
That's great advice. I mean, if people want more information or have questions from the podcast, what's the best place to go? Is it best to go to the Microchip website or somewhere else?
So you can go to the Microchip website for sure. And you can go to the oscillator section, or you can go to the space section and find the products that way. And what I would suggest, if there's a question on the majority of the oscillator pages, you're going to find the contact me button. It will send an email to vop-support@microchip.com, and it will come directly to our team to connect you up with the engineers to engineers and get the questions answered.
That's awesome. Dave, this has been just a great podcast, really fascinating. Thanks so much for explaining why Microchip is timing in space.
Thanks for listening to the Microchip Is podcast. Please follow us on your favorite podcast platform to keep learning about the many technologies, products, and people that make Microchip what it is today. Look out for our upcoming Microchip Is podcasts and our new Beyond the Microchip podcast series.